Okay, so today we're going to do another Leetcode problem. Let's just get started. So the question is called add two numbers. So you are given two non-empty linked lists representing two non-negative integers. So from the image we can see the linked list. So it's essentially the list itself represents a whole of an entire number. So it's like 243. Represents two non-negative integers. Okay, so it's whole numbers, right? 0 and above. And the digits are stored in reverse order. Okay, each of the nodes contains a single digit. Okay, so each node has one digit, and for example, if this number represents 342, so so what I'm thinking is, as you go through the number, each number that you encounter represents like the next order of magnitude, like the next digit in the sequence of numbers, right? Okay, so add the two numbers and return the sum as a linked list. Okay, so I have to return the sum also as a linked list. Sure. Okay, interesting. You may assume the two numbers do not contain any leading zero except the number 0 itself. What does that mean? The numbers do not contain a leading zero, so the first leading zero means zeros before the number, right? So essentially the last number is not going to be 0 except the number 0 itself. I don't get that part, so let's read further. Okay, so input L1 is 243, L2 is 564. It's a simple array, so it makes things easier for us. There's no need to look for the next node. Okay, so input is so I'm supposed to okay, 243 and 564. So essentially add these two. So this looks what I'm thinking is I can just treat this like you do simple addition, right? Like you look at the units place, you add the numbers together, take the remainder, like whatever's extra, the carryover thing, and you carry it over to the next round of addition. It's a simple addition thing, right? So that looks simple enough. If from the face value it looks like they're asking us to do junior high school, I mean like to 8th, 3rd standard addition in a way that's written in code, right? Okay, so so this one I get 5 plus 2 is 7, 4 plus 6 is 10, so that's a 0, and 1 gets carried over, and 3 plus 4 is 7, plus 1 8. So okay, let's get to the next one. So except the number 0 itself. So maybe this is what they mean. So there's a possibility that the input could be the number 0. Okay, and this one 99999. So okay, so this is one of the edge cases, I'm guessing. So the inputs can be of different lengths. That should be simple enough because our algorithm just should really focus on just adding the two numbers together iteratively instead of focusing on how long the numbers are. Okay. Okay, so constraints, the number of nodes in each list is in the range 1 to 100. So okay, so each linked list can have a maximum of 100 and a minimum of 1 element, and node value can be anything between 0 and 9. Cool. And it is guaranteed that the list represents a number that does not have leading zeros. I'm curious about how that would change the approach that we're taking. I guess we'll have to just try it out first before coming to any conclusions. So let me just think about how we're going to solve this. So I'm thinking I'm going to take the two inputs and I'm going to write a for loop. And the for loop should be the length of the larger array, right? Because that's how long we need to conduct this operation. So we're going to find out the length of the two arrays first, and we're going to loop from 0 to the length of the longer array, and for each iteration we have so each iteration is essentially a place, right? It's like units place, cents place, hundreds place, that kind of thing. And I'm thinking at each level, once we do the operation, if the number is if the value that we get as sum is greater than 0, greater than 9, then we just do a modulo 10, and we can put the remainder as whatever's in that place and carry over the rest. So normal addition, right? And okay, so one other thing that I need to think about is how I'm going to represent the output, right? So I can't just find out sum. I need to store it in some kind of array. So right off the bat, I'm thinking I can just make a new array. So it says linked list, but we're working with arrays here, right? So it makes things slightly easier for us. So I'm just going to make a new array, and as we conduct the operations, I'm going to push new elements into the array, and that should be fine because we're going from the units place to higher numbers, right? So let's just get started. Okay, so this is our editor, and okay, I'm just going to write it for. Okay, let me just look at what they're looking for. Okay, definition for single linked list class. Interesting. So okay, here they gave us an array, but it's not actually an array. It's going to be a class, a linked list. Okay, I'm just going to copy the whole thing here, and boom. Okay, I wrote an L2. Could be null. That's strange. Why would it be null? List node, add two numbers. List node. List node. Okay. Okay, so okay, this makes things slightly more complicated because one second. So this one is 75 null. So I don't really understand why they're including undefined cases, because clearly from the type definition it can either be a list node or null, right? So why look for undefined? And value can also only be number, right? Okay, so it's optional. Fine. Okay, so let's not pay too much attention to that. What I'm actually interested in is the fact that instead of giving the whole thing as an array, which was what I was planning to work with, we've been given two nodes. So our function should essentially work with two nodes. Let me see how that would work. Interest presenting. Right off the bat, I'm thinking this is going to be some kind of a recursive thing. Two numbers. So this should output a list node. So this is not how I would approach it. I would have appreciated something that was similar to these lines, in the sense that instead of giving us an array in the examples and list node here, we would have had both of them using the same kind of approach. So let's just work with what we have right now. So I'm assuming that it's going to be called like add two numbers, and it's going to be like L1 and L2, and L1 is going to be new list node. Just going to use it, and let's just make this define that. Oops. Okay. Okay. it's a new list node with a value of next one is some L1A. So I'm just trying to maybe let's see where this goes. So it's just 2, next one is L1. So this is how it would get constructed. And let's say this is the end of the chain running. Yeah, okay. So let's say this is, we try that again. So this is two numbers like L2A, and let's say this is like 1, this is 3, L2A and L2. Okay, so essentially we're given the first node in the linked list, and we have to find out, we have to add the whole thing together. Okay, so we have to add the whole thing together, and we're going to output the first node in the linked list. Okay, we can approach that. So right off the bat we have to use. So I'm going to try and use the iterative solution. Just simply because it's easier to get started with, and so if it's let's see what I would do. So I'll write the loop later. I'll just do the things manually right now. And okay, so L1, right? So I'm just going to name this Li, just so that I'm not confused with the other thing. Li2. Okay. So L1 is our first thing. What we need to do is so right off the bat, I'm thinking there would be a really easy way to solve this. Okay, these are two things we have access to. So let's just let carry over. So once we conduct something, there's going to be a carryover, right? So if it's 0, that's our starting number, and we have to do L1.val. How can the value be null though? It has to be a number. Why would the okay. This is what I need to do, right? So sum is this, carryover is going to be sum modulo 10. So we can assume that the number is going to be less than 20. It's going to be definitely less than 20, because each node, the value of each node is single digit, right? So single digit has to be less than 10. It's given in the conditions too. Constraints here. So this part. So it should be, I think, maximum number it can be. It's like 18, right? 999. So carryover is that, and the one digit sum. One digit sum is going to be sum. So okay, we just do if sum is greater than 10. Is it greater than 9? Yes, greater than 9, right? So if sum is greater than 9, we need to do this stuff. So I'm going to do sum left. If it's greater than 9, I can just subtract sum minus equal to 10, right? Because it just works. I could do the minus divide by greater. So this is the carryover. Wait a second, I'm thinking of this is what's left, right? Sum is the remainder. The carryover is going to be it's the maximum number it could be. You can figure this out in a different way, but since the constraints are so clear, you can just hard code the carryover number. It's definitely going to be 18 is the maximum number. It's just going to be the sum is going to be the what are the remainders after dividing by 10. Cool. After that, what we need to do is so how do we put this as an output, right? So this was easier to do in an array since I can just push. So in a linked list, I will just how do I do this in a linked list? I would have to create the linked list. Okay, so let me just create a linked list over here. So list result list starting node is new list node. Do I have to set a number? Okay, so I have to. So I just initialize it sort of as a reference, and I can create constant actually. Yeah, okay. Yeah. So after getting the sum, I can just result list starting node is new list node. It's going to have a value of sum from the next node. Okay, so I have to find out the next node, right? So next node can be. So next node only exists if this number is greater than. That's one option, right? If next node only exists. So what are the conditions under which? When does next node exist? So it exists when sum is so this condition over here is carried over sum is greater than 9 and is carried over. So it has to be that. Do I care about that? I guess not. So that doesn't matter. So the next node exists if essentially either of the lists has a next node in the chain. So I'm going to deal with the question marks now, or maybe later. Let's think about it. So if this next stuff exists, I need to think about. Looks like we're coming to a recursive solution anyway. interesting. So okay, so I'm thinking as long as there are so let current node A list let current node B is another node list. Let's just we can start it out. So as long as okay, so let me just start this off with a value. Okay, this is going to be N1 and this is going to be N2. So what happens if one of the numbers is null, right? So if the first list is null and the second list is both are null, I should return should throw an error is what I should do, because stuff doesn't work anymore. So error one, yeah, whatever. One list should be valid. But if it's like or two. Case. Okay. That's the case. How would I do this? N1 or N2 is okay, so if one is defined and one is the other one is null, I would have to just return the result as the first one, right? So instead of so that still works for us because it can be. So let's see what the type inference is saying at this point. So type inference says it could be list or null. Okay, so while there is a next node, node A is a next node B as a next looks like I might have to use the do while loop. So do it at least once, right? Maybe it would help if I thought about the problem a little bit more in terms of how I would do it. Okay, so while the list has more nodes pending, I should keep adding them, right? So the two numbers. So while the list has I know at the end I need to convert a next and cannot be is only cannot be my next. So what is the thing that I should do, right? So since I don't find it wrong, that's what I'm gonna say. So what is it? So I need to do some kind of simplification. It's going to take the download value, it does have a value, and add it to download the value, it does have a value, you get the sum. So the sum is going to be select sum. If the sum is greater than 9, I can just sum 1 to 10 is the sum sequence, sum 1 to 10, and then the carry over is going to sum minus 10. No, it's going to be 1, right? It's going to be 1. I'll just say it's true. So carry over is false is how it starts. Let's say carry over is true. So effectively, if this is true, it should affect this calculation that's going on, right? It should say plus carry over is true. Add 1, otherwise don't add anything. Okay. Let's see what's going on. So value could be this part is just so the node could be undefined, right? So if that's the case, we'll just put a 0 and the other one will just do this one. So for clarity, I'm just going to clean this up a little bit. That one is this one, and similarly that 2 is going to be okay, 1 plus that 2, just carry on. Okay, sums greater than 9. just going to create no else, else the carryover is now. Okay, I don't need else. I can just set it over here. As soon as the carryover work is done, I can just set carryover to false again. So it's going to loop. So what's going to happen is initially it's going to set first node as A, second node is L2, and it's going to start with the carryover of 0, which is indicated by flag of false. And while there are next nodes available, while at least one of the linked lists has a node left, we're going to get the value. So the default value is going to be 0, and we are going to add those two values together. So even if the list is empty, that is, the node could be null, or if the value is undefined, it's not going to be undefined. It's going to be a number, right? So if it exists, it's going to be a number. If it doesn't exist, we're just going to pass it to 0. So this should work. And after that, if the sum is greater than 9, we are just going to take the modular of the sum, which gives us the remainder after divided by 10, and we're just going to set the carryover to true, and we are going to continue that process for the next node in the series. Okay, so the trick is I need to set this somewhere. I need to put the sum somewhere, right? It's not being used anywhere. So I'm getting the sum, and let me just let me assume that I have to set it at new node is new list node, and it's going to have a value of sum. Okay, so I have to tell it what is the next one I'm going to point to. So this should either be another list node, some kind of node, or it should be none, signifying that the chain has ended. So it seems like if I have to tell it about the next node, I can only do that once the previous node is determined. So what I'm going to do is I'm going to move the sum also over here, and after this stuff is over, this is interesting because let's just say this is previous sum, okay? So the sum is this, and I'm going to set previous sum as current sum. Before that, I'm going to create a new list node, and I'm going to set the sum as sum. Okay, so the question is, why do I need the previous sum now? It seems like I'm going to have to use instead of the previous sum, let result node. How the fuck do I put a value for result node? I need I can only do it once this thing. Once. I have to set it to the sum, but I also have to point it to the next one. How do I do that? How do I create? So right off the bat, I'm thinking just create a sum and next node, and I can just do a next node here, and it's going to be half. I don't know. This is going to point to. Okay, so this is the next set of problems we got. I can't create the node until I know the next one is going to be in the node. So I would modify this to just set the next one using some kind of method, but I think that's going to be cheating, so I'm not going to do that. Instead, let me just think about this. We delete this previous sum, and I'm going to do this. Really interesting. It's public property. It's public, right? So I'm just result node, result starting node is a new this node, and it has a value of 0 and it points to nothing. So can I modify result starting node? That's going to get easier with the days. Okay, so I can modify it after the fact. I'm just going to start with the result starting node initially. Okay, and I'm going to, apart from that, I'm going to say current result node is, yeah, I'm just going to start with the result starting node. But after that, let's just, so after we find out the sum, I can just current result node, and look at the current result node and set the value to sum, and after that I can just sorry, I also need to point it to the next one, right? So I'm going to point it to the next one. Next. I could just add some kind of edge case, which the result starting node is some kind of undefined or null. And I would assume that inside the loop, okay, that means that the list is just starting. So let's think about it a little bit more. Or I could just do some kind of first case outside of the loop. So that would make more sense. Because then I would have more control too. Once the result is calculated, I can just, why don't we just create the next result node and set it as no. Okay, so that's interesting. So what's the next result node, and I'm going to create a new this node. It's going to be 0 and none, and what I'm going to say is current result node value is going to be sum. Current result node dot next is going to be next result node. Okay, so after this I can dispose of all references to this current result node along with So I can skip. Can I just another thing about so, current result node is going to be it's going to be the next result node. Okay, and yeah, it looks like this loop is going to work. It would have been harder if I had to do this in a sort of a one-liner, but since we can define the stuff in one place and modify it later on, it makes things a lot easier. Probably there's a more robust solution involved if we had to do it in a more in a way that does not allow for modification after the fact. So at the end of the loop, I can just return the result starting node, right? And sure. Okay, so instead of this, I guess I can return null if both are null. Equal to null. Yes, this is what they were looking for. So let me just try and run this. So there's a good chance this couldn't work. I'm assuming that the loop part is where I should work on a little bit more. Okay, so I would run this locally, but I think I have the inputs in the correct way. Let me just paste it. Let's just try running it. Wrong answer. Oh, 3. Okay, one case passed. It's 0. Let's see what didn't work. Okay, 7-0 is fine. Guess it didn't work the last time. The output was 0, but expected 8. Okay, case 3. Okay, so somehow it's failing on the last round. How did it give 0 when it was supposed to be 8 though? Let me check that. 4, 3, 5, 6, 4. 3, 5, 6, 4, right? So both of these, this condition is going to be true because, what is it? Okay, so when there's no, okay, so that's the part that became problematic, right? Because when we reach the last element of the loop, we don't have any following node. Instead of doing it once, stopping the computation, what we're doing is we are what we're doing is we're skipping the last round of iteration because there is no this condition checks if there is any node remaining. So the thing is, even if there is no node remaining next, it should work. So it should not work when current nodes are not. So let me try it for this one. I'm just going to check if both nodes, if either of the nodes are defined, we can simply go ahead with our calculation. This should work better. Let's see what happens. Just try running it again. And so 8, 0. Okay, so there's one extra. Where did I go for the extra time though? Since we're not supposed to run the next time. So creating an extra node, even though the thing was supposed to end. So that's interesting. So, we have to assume that the chain has ended at every single point. Let's see how that would work. So current result node. So I think I should point it to null instead of the next result node should be null, right? And wait a second. So initially I can assume that it's going to start out, but as the thing progresses, once I get the sum, I can be confident that I should add something to the previous one, right? So at this point I'm going to assume it should be, so this can be either a list node or no. Two things. So okay. So okay, so at this point we can find it. That's just not going to show what I expected it to do. No, that's fine. It starts off with some node. If there is a sum, I can say that okay, I need to create, I should delete this part from scratch. So if there is a sum, I need to create a new list node with the value of sum, and that is not pointing to anything else. I need to new node, and I need to point the previous node, and result node to value to not value, I need to go to the next one. Okay, let me just think what happens. When does the current result node become null? It becomes null. But instead of doing all this stuff, could just at the end of this whole thing, I could just set the current result node. Okay, so I can't backtrack, so that's another negative. So I have to use the right way. Okay. So when does the current result node equal to null? So that's every single time, right? So I have to assume that the previous node is the last node. So So I only add the nodes as they have a value. Okay. So as soon as I find out that I have a sum, I can set the next value to be wait a second. Okay, so as soon as I know that I found a sum, I can create a new list node, the value of sum, that says that okay, I'm the last one in the list, and that is my current node. And then what I have to do is my current node, I'm going to put a new node. And what I have to do is the current result node. Now next one. Current result node, not the next one. I'm going to point it to the new node. And what I'm going to do is the current result node is going to be the new node. Okay, so the step I'm going to put this here. So it's the part that we I have a problem with is that this is going to work only for, this is not going to work for the first round iteration, right? So because there is no current result, it does not have a value initially. So how is it going to do it for the first one? So I'm just going to put a simple if case. We can result starting node is null if the current result node is null. So that acts as sort of a flag to tell us that this is the first one in the list. So what we can do is current result node is new this node. It's going to have a value of sum, and it's going to point to nothing else. This is our normal case. Just create a new node, the value, and so we can clean this up a little bit. It's a new node, and yeah, so this should work. Okay, so we're going to create a new node. So if this is the first one in the whole list, we just start off the list, and if it's not the first one, we can just point the existing list to the new node, and I should tell it what the last element of the node is, of the list is. Excuse me. So I'm going to copy this once more, and I'm going to paste it over here. Okay, and we'll hit run. This should work. I'm pretty confident in this one. Yikes. It's getting worse. Why didn't this work? Can't even debug this locally because this stupid array thing. Why didn't this work? Didn't this work? Is it that one? Definitely not that one. probably it's do something very stupid. You know, let me try that. Something horrible going. It feels like it didn't even enter the whole thing. Yeah. Okay, so really stupid thing that you did. So I returned result starting node, which was initialized to null. So really way for me, a really easy way for me to solve this is just create a new list node. The value is going to be 0 and null. And just create basic flag is that is first node true. Really easy way to start things off. So instead of doing this, I can just say this first node, then so what I need to do is result node dot value is sum. And I don't need to point to do anything else. So sure. Okay. So at this point, the current result node will always be a list node, and I can get pretty confident that the whole thing is going to get chained. Okay. So for the I don't know how many at time, I'm just going to try it again. Okay. So like I said last time, I'm confident this should run. Let's see. is the last one? It almost seems random at this point. Let's see how long we've been going though. We have been going for fucking hour. Shit. I don't know what to do at this point. I would have liked to debug this. So, since it's an array, I don't know how to proceed. Interesting. Yeah, so one very stupid thing that I did is after this first one I should set it as false. Okay, so the first two cases are done. It's good. Let's see why I got the last one wrong. So output is 0, 0. I wonder why. I wonder why x prints 1 plus 9 is 88, right? So 8, right? Okay, so somehow the sum isn't running, the sum function isn't running when it gets to the last iteration. So it stops here for some reason. Let me just see why it isn't running. So this is fine, line 9 it gets added up as long as it can. After that, it's just add it, takes the carryover, adds it, takes the carryover, adds it, takes the carryover. This is running the last time. So as long as what's going to happen? Let's examine the case that happens when it runs for the last time. So it's going to be 9 is going to be the current node in the first one. The current node B is going to be null. So that's fine. So value 1 is going to be 9, and value 2 is going to be 0 because it's this one as well. So it's obviously null. So the sum is going to be value 1, which is 9, plus. Okay, so I think I'm resetting the carryover at each round. It's just a guess. Let's see what the situation is. So the sum is going to be 9 plus 0 plus carryover is going to be true. So it's going to be 1. So 9 plus 1 is 10, and I set the carryover as false. What happens next? So it's 10, right? So it's greater than 9. So the sum is going to be okay. I think I sort of understand. The sum is going to be 0, and the carryover is going to be true. So this depends on running one more time to add the last. Let's see what happens. Is first node. Yeah, so it's not, this is not going to run because it's not the first one. And this else part is going to run, and it's going to create a new node. The value is 0. It's going to point to nothing. And it's going to set it as the last class set in the sort of algorithm we have. In the linked list, sorry, it's going to set a new node with a value of 0, which is pointing to no other node, as the last element of our linked list. And I'm looking. I think I can solve this in two different ways. So one way would be to check for the carryover after all of the stuff is run basically here, and if there is a carryover, just add another node to the end. But I think that would be a sort of bad way to do it. So it would be similar to this one. So I think an easy way is to just check for a carryover over here. So if there is a carryover, so I'm going to add that part to my conditional checks. I'm going to run it again. So if there is a carryover, it should just get 0 plus 0 plus 1. It should just add another node to the thing. Alright guys, that took a lot of time, but at least we stuck to it, and we got through to the end, and hopefully I can do it in a more cleaner way. I'm going to try this in a different way in another video, hopefully a bit more cleaner. This was a very messy solution, and I think the recursive solution is going to be a much cleaner way to do this. But yeah, at least we solved it, right? It's going to count for something. I guess this is literally the second problem I'm doing on Leetcode. Yeah, good experience, I guess. See you guys in the next one.